Believe me, there has been a beginning. It is a beginning. I don't think there ever will be an end, not as long as man is alive and willing.
Constellation is NASA's program to return humans to exploring beyond low Earth orbit. We've begun with the end in mind of exploring Mars and understanding what is it that we need to learn between now and then in order to be able to do that safely and effectively. We have three different, what we refer to as design reference missions. The first one is servicing the International Space Station. Insert into orbit, rendezvous and dock with the International Space Station, stay up to 180 days or more at the International Space Station, and then return that crew to the surface of the Earth. Design reference mission number 2 would be to do a 7-day mission to the Moon. Design reference mission number 3 is sort of a combination of those first two, because we're doing essentially the same functions that are in the space station mission and in the lunar 7-day mission, but now we're having crews stay on the lunar surface for up to 6 months at a lunar outpost. We have a very rich heritage of human and robotic exploration of the solar system. The extent of our reach was the Moon in generations past. With humans, Constellation is about reaching beyond that point ultimately.
The Orion system is basically the capsule and the supporting system that'll get the crew into space, into docking with the ISS, and eventually onto the Moon. So that's where the crew sits. That's where the crew does its job. On Apollo, we had a capsule shape, and in that mission also we were going to the Moon. This is different now because the mission on the Moon is different. We're now going global access on the Moon, meaning we want to be able to go to the poles where we might find ice and those kind of things, which will help us sustain ourselves there longer. To do that requires a different vehicle, right? More propellant than we had on Apollo. We also want to be able, when we're on the Moon, to have a sufficient crew to actually do a lot more EVAs to get out there and actually do work. So that's why we're sending 4 people to the surface. So given those two changes, this Orion system is much different than Apollo as far as the size and the other capabilities. Now to get Orion in orbit, you need a booster. So that's Ares 1.
The Ares 1 is what we call the crew launch vehicle. It's made up of a first stage, which is derived from the Space Shuttle solid rocket booster, except it uses an extra 5th segment, and with a liquid oxygen, liquid hydrogen upper stage powered by a J2 engine, which is a derivative of the old J2 engine that flew on the Saturn V. The Ares 5 is our heavy lifter. This vehicle can lift 6 times the cargo anything on this planet can lift today. It's got the same solid rocket booster surrounding a liquid oxygen, liquid hydrogen core stage, which is double the size of the external tank today. And it has an upper stage as well. We call it an Earth departure stage. That does 2 things. One, it takes the lander into low Earth orbit. And after that docks with the Orion, which is what the Ares 1 takes to orbit, it does one final burn and injects the stack on its way to the Moon.
The lunar lander is part of the Constellation program. It has a mission of taking 4 people back to the surface of the Moon. In this architecture, the crew is actually launched separately from the lander You launch the crew in the Orion vehicle on Ares 1, and you launch separately the Earth departure stage and the lander on Ares 5. Both of those go into low Earth orbit. The Earth departure stage and the lander rendezvous with the Orion vehicle in low Earth orbit. At that point, the Earth departure stage does a translunar initiation burn, and we go to lunar orbit. You drop the EDS stage along the way, and you end up in lunar orbit with the lander and the Orion vehicle. And at that point, they separate. The lander goes down to the surface of the moon. We leave the descent stage on the surface of the moon when our mission is done, and only the ascent stage returns to orbit. We re-rendezvous with the Orion vehicle, and then we extend the ascent stage. We have 3 different missions. We have one mission which is a sortie mission, and it takes 4 people to the surface of the moon for 7 days. They actually live out of the lander in that mission. We have a second reference mission, which is an outpost mission, and in that mission, the lander takes the crew to the surface of the moon, but the crew then lives out of the outpost. In that mission, the lander actually sits dormant for approximately 6 months. The third mission is a cargo mission. That is an uncrewed mission. It's an automated lander, and that's what you would use to bring heavy cargo to the surface of the moon.
You look at some of the choices we've made in the systems we've chosen, the solid motor from the shuttle, the upper stage engine from Apollo, as starting points for what we are going to build. That gives us a great advantage. So what we see going on here in the early part of the program, with the test firings and the different things that we're doing, much of that is to anchor our analytical models and the design tools we use, to then go and improve the design in key areas. We have every center of NASA's team engaged in this program at nearly every level. I've been incredibly impressed with the depth of talent this agency has to offer. And we're taking that and we're applying it to the really tough problems of constellation, of exploration, of being able to actually push out to the frontier.